Alrighty, hello mathematicians. Today's objective, 110B, is students will be able to find least common multiple, which is the LCM, and apply to word problems. Okay. Hit pause and get this down. Alright, again you should have hit pause and got that down. The first word is multiple. Okay, so you should be thinking, what do you know about a multiple? If you had to guess, okay, what would you say a multiple is? Again, don't just wait for me to write it. You have to be thinking before we write. Okay, a multiple, we say, is the, let me zoom in a little bit here, is the product. The product. And product, we always got to remember this and write it down. Product means multiplication. Okay, the product of our given number and any other number. Okay. And we'll go over some examples of these. Alright, a common multiple. Well, we should know what common means. It means that like something that's shared. Like if you and I have a hobby in common, it means we both like to do that hobby. Okay, so a common multiple is simply when two or more numbers share, and hopefully you have a little bit more room than me. I'm actually making this video from Washington, D.C., and I don't have my little pen at home, so I'm using my fingers, so hopefully you have a little bit more room. When two or more numbers share the same multiples. Okay. And let's underline share the same. And let's underline multiples too. Alright, least common multiple. We just added one word to it. Least means the smallest, so it's simply the smallest of all the shared multiples. Okay, get that down. If you're like me though, you need examples to help you with definitions. Like I sometimes struggle to just read the definition. I always think about it, but still I need some examples. So we're going to go through a few examples together. Let's change this. Example 1, it says find the first 10 multiples of 4. Let's just change that to 5. If we find the first 5, you guys will get the hang of that. We don't need to do all 10. Okay, multiples. Again, the product of our given number and any other number. Well, our given number is 4. Okay, so we're going to write, this is the work that we expect to see on every problem. We're going to start with a 4. Product means to multiply. We always start by showing, oh, we're going to multiply by 0. Multiply by 1, multiply by 2, multiply by 3, and multiply by 4. Okay, and I think that's the first 5. Okay, 4 times 0, okay, so get this just below it. 4 times 0 will give us 0. 4, that's an ugly 0. 4 times 1 will get us 4. 4 times 2 will get us 8. 4 times 3 will get us 12. 4 times 4 will get us 16. Okay. Those are the first 5 multiples of the number 4. Okay. Next one, find the first, let's change this to 5 again. Find the first 5 multiples of negative 2. Well, we really need to work on organizing our work, so let's draw a line to separate these. So we're going to start with negative 2. We're going to do the exact same thing. We're going to show what we're multiplying it by. So we're going to multiply it by 0, multiply it by 1, multiply it by 2, multiply it by 3, multiply it by 4. Okay. Negative 2 times 0 will give us 0. Times 1 will give us a negative 2. Times 2 will give us negative 4. Okay. Times 3 will give us negative 6. Times 4 will give us negative 8. Okay. Again, those are the first 5 multiples of negative 2. Alright, this should be pretty simple. Okay, if you get stuck, use the exact same problems that we just went over, showing the exact same work. Change this to 5. And you guys may have to tell Miss Moran that in the video, you know, I said to only do 5, otherwise she'll think you didn't do them all. So, you guys do these on your own, set them up. Once you're done with them, you know, you can unpause it and I'll have the answers here for you. So right now, hit pause, do these next two on your own. Okay, check your answers with mine. These are the first 5 multiples of each of those numbers. Okay, if you got one wrong, make sure you mark it wrong. That way when you go back to study your notes, you know exactly which ones to study. Okay, the directions for these say find the least common multiple of each set of numbers. Okay? Well, whenever you guys come across words, you have to break down these words and phrases and think, what do I know about each one of these phrases? Least just means smallest. Okay? Common means they both or all share. And multiple, okay, we already talked about. Now, for multiples, I personally find it helpful to think about multiples as typically being the numbers that are bigger. Factors are typically numbers that are the smaller ones, okay? So, now, again, that's just the way I think about it and remember them in my own head. Okay, so multiple, again, is the product. So we're multiplying our number by other numbers. Okay, number 1 says to find the least common multiple of 4 and 15. I want to change this one as well. Change this to, let's change it to 16. Okay. Okay. Now, we got to find the multiples of both of them and then find which ones they have in common and then take the least of those ones that they have in common. So we got to do for 4 and for 16. And we're going to start with times 0, times 1, times 2, and so forth. Okay? So 4 times 0 is 0. 4 times 1, 4. 8, 12, 16, 20, 24, and so forth. Let's just stop there. 16 times 0 is 0, and then 16, 32, 48. Okay. Now, here's a key point on this. Okay. 0 is a multiple. However, it's kind of a tricky multiple. And we don't consider it to be the least common multiple because 0 would be a common multiple to every single number. Okay? So we typically don't consider it to be the least. So let's write a key point on this. And the key point is we never consider 0 the LCM. Okay? We never consider the 0 the LCM. So we got to find the smallest number, the smallest multiple that they both have in common, and that one in this case is going to be 16. Okay, again, we found the smallest number that they both have in common. If you were thinking, oh, the smallest number that's not 0 is 4, okay, do they both have 4 as a multiple? The answer is no. 16 doesn't have 4 as a multiple. Okay, so our answer to this, the LCM, would be 16. That's your answer. Okay. All right. I'll help you get this one set up. So what's the LCM of 3 and 16? Well, we have to find the multiples of both of these and then find the common one. So right now I want you guys to hit pause and find the multiples of 3 and the multiples of 16 and make a list. Go. Hit pause. Okay, so here is my multiple list for 3 and for 16. If you do not have this, and I should just do 64, if you do not have this multiple list, I want you to hit pause now and make sure you understand how I got this list and get this down. Okay. Alright, I'm going to assume that you have this list down. Now we have to find the least common multiple of these. So I'm going to start with 16, and I should add 0 there was 16. Does 3 have 16 as a multiple? And the answer is no, so cross it out. Okay, 32 is the next smallest one that 16 has. Does 3 have 32 as a multiple? The answer is no. Then the next one we have is 48. Does 3 have 48 as a multiple? And the answer is yes. There's 48 right there. So the LCM on this one is going to be 48. Okay. All right, let's go on to the next one. Again, if you have questions, make sure you hit make a note, put a question mark, and write specifically what you have a question on. Okay. Let me give you the Smart Cut now. Okay, let me give you the Smart Cut now. The Smart Cut is this, and we kind of did it on this last one already, but there are 2 basic steps to a Smart Cut that'll save you a lot of time. Okay. First, find LCMs. Actually, let's change that. Not LCMs. Let's just do find multiples. Cross that out. Find multiples of largest number. Find multiples of largest number. Second thing we're going to do, so for example up here the 16, that's the largest number. I would start by finding the multiples of 16 first because that's the largest number. Okay, step 2 is we are going to divide by smaller numbers. And we want it to divide evenly is what we're looking for. Okay? So let me model that, how to use a Smart Cut in this next one, example 3 here. So we have 4 and 12, right? So we're going to use the Smart Cut. We're going to find the multiples of the largest number. So we have 0, 12, 24, what would be next? 36. I'm just going to list a few. And now, before I keep going with all the multiples of 12, I'm going to stop and check. Okay, 0 divided by 4. Remember, we're not counting 0 in the LCM. Okay. Let me go back and read this. So, example 3. If x is the LCM, so this is kind of a tricky one like we were doing with factors. If x is the LCM, I'm going to write that out. X is means equals the LCM. Okay. What is, and so many of you are making mistakes on spiral problems because you're missing things because you're not using cups. You're missing like what is the value of 3 times x. This one it's what is 6 times x plus 5. Okay. Now I'm just going to write this right now. 6. I got to figure out what x is. I don't know it yet. So it's 6 parentheses plus 5. Now x is the LCM, so we have got to find the LCM. So going back to this, I'm going to do 12 divided by 4. Does that come out evenly? 12 divided by 4. And the answer is yes, it comes out evenly. So that tells me, again using my Smart Cut, that tells me that 12 is the LCM. So 12 is what? X is 12. Okay, again, x was the LCM. Well, now I know that the LCM is 12. So it's x equals 12. Now I simply have to plug that in. 6 times 12 would be 72. Plus 5 will give me 77. That is your answer to this problem. Okay? Alright, I'm going to show you that Smart Cut one more time. Just really quickly. So if I'm finding the LCM of 6 and 9, I start with the larger number. I start writing out the multiples. 9, 18, 27. I like to do 3 at a time, check it, and then if it doesn't work out, I'll do 3 more. So right now we're doing 9 divided by 6. Does that come out evenly? The answer is no. Okay. Next we'll do 18 divided by, again, the larger number, the multiples divided by the smaller. 18 divided by 6, does that come out evenly? And the answer is yes. So what's the LCM? The LCM and again we need to write this out, is equal to 18. Okay. Again, if you have any questions, make sure you hit pause. Hit pause, you can rewind it, you can write question marks, but make sure you come knowing what questions you have to class. Okay, we're going to skip to this part, which is on page 17 here in the middle. Okay. Let's see. So the question is, why do we need the least common multiple? Well, it's helpful for a couple of reasons. The one we're going to focus on now is simply to compare fractions. Okay. So problem number 1 says, can you put the following fractions in order from smallest to largest and be willing to turn in your answer for test grade? And do this with no calc. Can you do that? Okay. Gets a little tricky, right? Especially without a calculator. What makes this so hard is that we don't have a common denominator. We can't really compare fractions unless they have a common denominator, especially without a calculator. If we have a calculator, we can divide them out to be decimals and see which decimals are bigger. But without a calculator, we need to have the same common denominator. Alright, some essential vocab. And you may say, oh, Mr. Irwin, I already got this. Why are we going over it? You guys make silly mistakes and you don't always use this terminology like you need to in class. So the numerator is the top of a fraction. We should know this, but from now on in class, we don't want to hear you say the top. You need to say the numerator. Okay? If you go to the doctor, they're going to use the correct terminology. They're not going to say that thing that pumps your blood. They're going to say the heart. They're going to use the proper terminology, and that's what we got to do in math class. The denominator is simply the bottom. That's an ugly B, and it just keeps getting uglier. The bottom of a fraction. Okay. Least common multiple, we've already gone over that. Write it in, try it without looking back, but double check to make sure that you got it correctly by looking back at what we wrote. Now, the least common multiple, it is abbreviated as the LCM. Okay. Alright, so let's go to the next page. I want to go over a couple problems. Okay, on the next page, it says we have two fractions, and it says to find the least common multiple. Now, it's important to know that we're actually, we're really finding, if we're talking fractions, we need to have the same common denominator. So what we're actually trying to find on these is really the least common denominator. And get that written in. Again, whenever we're looking at fractions, we want to have the same denominator. Okay? So on this one, our denominators are 4 and 15. So we have to find the LCM of 4 and 15. Okay, again, use the smart cut. We're going to start with the bigger number 15 and start listing some of the multiples. Now, I'm not going to list, well, I'll list 0 and I'm going to cross it out right away because that's not, when we're looking at the least common multiple, again, we don't look at 0. So next I have 15. 15 times 2 would be 30. 15 times 3 would be 45. 15 times 4 would be 60. 15 times 5 would be 75. I'm going to stop there. I went a couple extra. Alright, now we need to divide them out. Okay, so 15 divided by 4. Okay, do it on your calculator if you need to. You should know it doesn't go into it evenly. It's going to get you a decimal. 30 divided by 4. If you do it, give you a decimal. Doesn't divide evenly. 45 divided by 4. Again, decimal. Doesn't divide evenly. 60 divided by 4. Yes, it does divide evenly. When you do that, you'll get 15. Okay, so 60 is the LCM, or the least common denominator, we should say. Okay, now we need to rewrite these fractions. And let's see. So the LCM, or least common denominator, was 60 on these. I'm going to come over here. Let's just cross this one out. I'm out of room. You guys might be too, and it's the same. So what we're going to do on this, we need to write 3 over 4 as a fraction, but we need the denominator to be what? What did we say the common denominator was? We need it to be 60. We're also going to rewrite 4 over 15, okay? But again, we said the common denominator was 60, okay? So what we need to do is figure out, well, how do I go from 15 to 60? What can I multiply by? Well, the inverse of multiplication is division. So on your calculators, do 60 divided by 15. And you're going to get 4. So that's saying the same thing as well. If I do 15 times 4, what do you think that's going to get me? That's going to get me 60. So I need to multiply the denominator by 4 to get to 60. Now, whatever you do to the denominator, you have to multiply the exact same number by the numerator. Okay, so 4 times 4 is 16. Okay. Now, on your calculators, to check it, do 16 fraction 60, or 16 divided by 60, depending on your calculator, and convert it to a fraction, or hit equals, and the reduced fraction will go back to the 4 over 15. That's how we know we converted it correctly. Okay. Let's do this next one. How do I go from 4 to 60? What do I need to multiply by? Well, to figure out what you need to multiply by, you can divide 60 divided by 4, and that'll tell you that, hey, to go from 4 to 60, I need to multiply by 15. Multiply by 15. Again, whatever you do with the same fraction, so we're only looking at this top fraction, you multiplied the denominator by 15, so you have to multiply the numerator by 15. 3 times 15 is 45. Okay? So 45 over 60. Okay? So we just converted both of those fractions to be over the same denominator. Alright. I think I'm going to hold off on having you guys do any more until class, because this video will be a little bit longer. Again, we're always trying to make sure that homework is fair, that you're not spending an hour and a half every night on math homework. So let's go to the next page. Go and flip the page, and let's do one of these word problems. Yes, some critical thinking. First of all, hit pause now, use cups. Okay, I'm going to model cups for you on this. Again, it's insane that some of you are still not using cups on a regular basis. When I look at the spiral correction, so many times it's, I didn't use cups and I didn't see this. I didn't use cups and I forgot this. Use cups. Get these problems correct. Okay, take pride in the quality of your work and not making silly mistakes. Are mistakes going to happen? Yeah. But don't let it be because you're too lazy to use cups. Okay, Julie and Marie are making bracelets out of beads. Nothing too important there. Julie is using 5 centimeter beads. So 5 centimeter beads. And Maddie is using 3 centimeter beads. At how many centimeters? So our answer had to better be something centimeters. Okay? Or we can just do cm. Okay, that's going to be our answer. Something centimeters. Will their bead bracelets first be of equal length, meaning the same, or they have a common length? Common length. Again, I'm just kind of thinking out loud as I read through this. Okay? Now, on this type of problem, you can draw a picture. I can easily picture, so I'm going to write J for Julie, and then M for Maddie here. And Julie's beads are 5 centimeters. Okay? Maddie's are 3, so they're a little bit shorter. Okay, so this is 5 and 3. Now, if Julie adds one more bead to hers, again, hers are 5. Okay, so what's her total length going to be at this point? It's going to be at 10 total, right? if Maddie adds another one, a 3, her total is going to be, so I'm going to write a 5 above, and the total is all right below. So this would be at 6 total. Do they have a common length yet? No. So Maddie would add one more. And now she's at 9. Okay? Well, she's going to keep adding because she's not caught up with Julie yet. So now she's at 12. Okay, now she's at 15. Now she's at 18. Okay, is this starting to look familiar as to what we're doing? Stop and think about a different way of thinking or solving this. Okay, now we'll let Julie get caught back up. So her next one is, do that a little bit longer. Her next one is 5, so that puts her at 15. And look right here. These are the same length. Okay, so at how many centimeters will their bracelets be the same? The answer is 15 centimeters. Okay, the answer is 15 centimeters is where the bracelets will be the same length. All we're using right there is multiples. Okay, because it's like, oh, if Julie has 1 bead, that's 5 times 1. If she has 2 beads, that's 5 times 2. 3 beads, that's 5 times 3. That's multiples, where we're taking that 5 and keep multiplying it by 1, multiply it by 2. Okay. Before class, do want you guys to try example 2 on your own. So this example 2, you need to have cups and work shown and do that before class starts. Okay.